I'll be talking about GEM today, which is Geospatial Energy Mapper. The invitation for this went out to the users of the Energy Zones mapping tool that opted for email messages. If you don't want those messages, respond or reply with unsubscribe to that message. But we'll use that email for continuing communication about the Geospatial Energy Mapper. Just to give a little bit of a background, the Energy Zones mapping tool was launched about 10 years ago. And it is a publicly available web-based mapping tool. The funding originally came from the American Recovery and Reinvestment Act through the Office of Energy, Office of Electricity, and they've been reorganized, so they're now the Office of Grid Deployment that this project is under. It was originally developed for Eastern Interconnection, which is the electrical transmission grid east of the Rockies for the most part. It was a collaborative project among three national laboratories, Argonne, Oak Ridge, and the National Renewable Energy Laboratory. And there were technical experts on each major energy technology or resource that worked together to develop the models and the data. And Argonne developed the portal itself and hosts it even today. After that initial project, we did quite a bit of collaborative work with Sandia National Laboratory as well, concentrating on energy-water nexus for the most part. So that's kind of a little history. And after 10 years, some of the software components of the EZMT became pretty dated, and we felt that it would be better to re-engineer it, rebrand it, and rebuild it. So really, it's the same tool repackaged, for the most part, the same tool. And we think the user interface is going to be easier to learn and just a friendlier, first steps of using it. Both tools are hosted currently, and the EZMT will continue to be hosted at least for the foreseeable future, as some of the capabilities are not fully migrated to GEM, and we have an active use of that site. So that was the home pages. This is just a snapshot of the actual mapping interface of both tools. So I thought I'd start with just a verbal comparison of the tools. I noted that when they were launched, so about a 10-year span there. One of the aspects of the Energy Zones mapping tool is the user account. So once you want to start using it, you need to register and go through a process to get your account activated. And then those time out after a year. And while, the plus side of that is we had a better idea of the users that were using the EZMT based on self-reported, organization and what state they're in and those sorts of things. It really became kind of onerous to have to go through that process. So GEM doesn't require registration. You can just launch it and start using it. I mentioned the original scope, which was focused on energy zone planning in the Eastern Interconnection. And that energy zone aspect of it didn't eventually result in energy zones being defined as they were in the West, but the portal was just a broadly applicable tool. So that name itself and its difficult to remember acronym didn't seem to serve the scope very well. So we feel that GEM is appropriate for national scale energy planning for the US nationally. And the data, content, and the modeling capabilities are available beyond the Eastern Interconnection now to a broad geographic extent. The mapping library of the EZMT currently has 371 layers. And in launching GEM, we went through those layers and selected the most applicable and updated content. So the GEM, it's roughly a little over half the number of layers as the EZMT. So it's a bit more focused and narrow, and some of the older data that wasn't updated has been discontinued there. It's all still available in EZMT. When we add layers, they're updated in both tools. They share the same library, so the same content is there. Mapping themes, which I'll demonstrate shortly, were added in GEM, and that helps streamline just getting started with the mapping session. A couple other contrasts is the modeling library is the same, and I'll talk more about the difference between the mapping and the modeling libraries later in the webinar. The models have been carried over. The EZMT has a corridor modeling capability that hasn't been migrated yet, so there's 3 models that are not in GEM related to that. And then the 3 last lines there are capabilities that exist in EZMT that will be added in the future to GEM but are not yet in the tool. So one of the things that may not be immediately evident is what is this tool useful for? And so here's a variety of questions that you can use GEM or the EZMT to answer. So, I just gave a couple example layers, but you can add data to the map and just investigate what's nearby or how do these correspond. And that's one of the great advantages of having a portal like this with so much data content is that, you can mix and match any layers together on the map based on your own needs, many of which may not be anticipated or thought of by the developers, but you could use it for all kinds of different purposes. You can get at very specific information. So, for example, the substation layer could be superimposed with the service territories for electrical service, and either look at the attributes of the substation or combine those layers together to find out, something like that question. Which locations are most promising for specific electrical infrastructure is something that GEM and EZMT excel at through the modeling capability, which I'll be demonstrating. And that gets at really physical siting factors, so things like protected lands or proximity to the transmission lines or wind resource. All these different siting factors come into play for electrical infrastructure being viable or not in a particular location. And then we've added a lot of equity data recently, so you can perform the analysis and add equity metrics that help you gauge whether your project would, benefit or harm a particular disadvantaged community. I won't go through the rest of these, but these are the sorts of questions you can answer. Just wanted to also briefly mention a few recent technical reports. Most of this recent activity involves electric vehicle charging stations and electrification of transportation, often with an equity side to it. The report in the center was produced directly by DOE and includes EZMT analysis, and it's specific to each state. So any particular state would have one of these, and part of the content is customized with examples for that state. And it illustrates some available planning tools, online free mapping tools that DOE provides through their funding that would help with electrification analysis. Let's see, a little bit more on the report on the right, because this gets deeper. So if you really are interested in modeling capabilities and the process and want to really understand the details of that, this report would be pretty useful. Again, it's focused on electrical vehicle charging station siting, but it could be applicable to wind turbines or solar if you just kind of follow the same framework and apply it to that topic area. So the rest of the time, I'll be focusing on just giving a live demonstration, and I'm not really able to follow the chat actively while I'm doing that, but I will circle back to it and answer questions after I finish the demo. All right, so starting with the home page for GEM, it's at just simply gem.anl.gov. And if you click the button at right, oh, before I do that, I should mention the subscription list. Because we don't have registrations anymore, as new users start using GEM, we'd like to be able to alert you to updates or just talk about different capabilities of the tool. Typically, we don't send a whole lot of information out, so you won't get spammed a lot. But if you subscribe there, then you'd be including it in a mailing list for the tool. All right, so you click Launch Gem. It opens in a new tab. So if it doesn't, you'll probably have, you're blocking the pop-ups, but normally that would open up for you. And you're presented with these three panels. The middle is a map that's interactive. It's a lot like Google Maps. You can use your mouse wheel to scroll or to zoom in and out. You can pan once you're zoomed in. And once you start populating the map, you can click on features to get information about them. So it's a pretty straightforward. The lower left is mapping themes. These are able to be easily updated and added to over time. So we'll be adding more mapping themes and updating the content within them. So if I just pick, say solar, what it does is it rapidly populates the map with content related to solar energy resources and projects. So that populated the panel at the right, which is used to control the map content and the map, of course. These panels slide out. So, for example, if I do that, I can have a full screen map and I can actively zoom in on features. If I click on one of those, you get a dialog that's going to the database to access the information. By the way, the performance of this dialog can be a little slow at times. It does get at the load of the server, but also the number of layers on the map and the number of features coming back. So if it takes a long time to return, you can reduce the number of layers on the map, or yeah, it could be even the load on the server. So what it found is I clicked on a power plant. So this is a solar power plant. And I can expand these and get other information about, quite a bit of information about the solar plant that I selected there. And as well, there's this solar potential PV data behind, and it actually found a whole bunch of records that were coincident there. So any of these can be opened, and this contains, kind of monthly estimates of solar potential with some assumptions about photovoltaic solar panels that would be receiving that. Going back to the map panel, if I want to remove something from the map, I can take it out completely by clicking the remove button. I can toggle it on and off, just hide or show it on the map with the center icon. And I can adjust the transparency and just, kind of make the map a little customized for what I want to see. If you drag and drop a layer, you can change the drawing order. So you just grab the title and drop it, and it changes the order of drawing of the features on the map, which can help if they're kind of getting in the way of each other, or, especially fill might overlap some features that you want to see. You could make it transparent as well to control that. All right. That's kind of just a quick tour of a quick introduction to start using the tool. However, the data library has a lot more in it than just these mapping themes and what they introduce by clicking one of those. So the data library, it's a little bit more detail here. It lists everything that's in the mapping library by default. And I'll just take a second to contrast mapping layers and modeling layers. So you've got three buttons at the top: layer, model input, and model output. Mapping layers are raw geographic information system data that are used in the mapping interface to view on the map. And if you pick one of these, you can also access the metadata for it, which provides a lot of background details about it. You can add it to the map either by clicking this button or the checkbox at the left. or you can download the data. There's only a few exceptions about download that, layers that aren't downloadable, and that's typically because, there's some data sets that are a couple gigabytes in size. They're just prohibitively large. There's only a few exceptions for download. What else? Okay, so model input layers, that's another library. If I switch to that, now I've got 97 layers. And these are used, they're really suitability factors for modeling. And they're derived from the mapping layers, all of them. But there's like a single metric that you can use to perform your, suitability analysis, which creates a map of areas where a set of suitability factors all coincide. Again, I'll get into that deeper. For this point, just know that any of the modeling library can also be added to the map. And, same functions as before, with the exception that we don't have the metadata because they're derived from one or more of the mapping layers and they're not downloadable. The model output, there's a whole series of models in the tool. So these are pre-computed results of any model, and you can just add those if you want to view them. Okay, so the data content let's go back to the mapping layers. The data content can be filtered by category, for example. So right now it's got everything. If I wanted to look at, let's say utility layers, then I can filter by utilities, and I've got a much smaller list of 37 layers, and I can maybe find those faster. Or you could even do something like wind as a keyword and have a set of layers, only pertaining to wind that are listed there. So that includes both the if the title includes wind, or if there's a keyword associated with the layer that would include wind. Those are just the quick things about navigating the catalog. So along those lines, let's just add a couple to the map to show, kind of that process. Okay, so here, the last one I added is at the top, but it kind of overlays the others. So I'm going to drag it down, and I'm going to make it more transparent. And I'm going to turn off some of the others. Okay, so now here I just have all the power plants superimposed with the wind technical potential, and I can zoom in and just kind of peruse that data as I like. Okay, let's talk about finding suitable areas. This is one of the unique and most powerful elements of this tool in EasyMT. And the models, as I mentioned earlier, were designed by kind of a team of subject matter experts for each of the technologies. And if you were to go in the EasyMT and click Analyze, you're presented with kind of this giant grid of all the possible choices. It's a bit overwhelming, and we thought we'd step users through those a little bit more specifically, so then you get kind of a much more targeted analysis. So each of the steps has this little, hover over help, just to guide you a little bit. And why don't we start with electric vehicles, because a lot of our, stakeholder and data activity on the tool and communication is in this area right now. So let's start with that. And for electric vehicle charging stations, we have 3 example models. And these 3 models are featured in that report that I mentioned. So they're described in detail, kind of all the objectives leading, what are we trying to map, and a lot of the rationale and the data. So that's all explained very thoroughly. And the appendix includes a step-by-step example of how to run that particular analysis in the EasyMT. I would say if you can run it in the EasyMT, you probably can run it in either tool without following those steps. But if you need that, there's an appendix there that allows you to see how that works. I'm going to just clean up the map here a second. So and by the way, I'm not very satisfied with this color scheme. So we'll be working on this color scheme and updating it. But what you're presented with is a map. It's just the lower 48 states. Unfortunately, we don't have Alaska and Hawaii in there right now for modeling. But it has a score from 0 to 100, and that represents a measure of suitability for the particular model objective. So the objective of this model is to locate or to suggest locations for new electrical vehicle charging stations along designated corridors, which are, designated to be built out for electric vehicle charging stations that don't already have stations. So if we investigate what's going into the model, we have all these different layers here that have some element of the siting factors that would be beneficial for that type of model. And each one of these can be expanded, and it's got a set of also values from 0 to 100 that get at the suitability. Let me start with a different one here. If we say, okay, so we have these designated corridors, and here we're saying that if you're within 1 mile of the corridor, we're going to have the highest suitability. And as you get farther away from the corridor, the suitability diminishes. And if you're over 5 miles from the corridor, you have very low suitability. So this will highlight areas of the map that are near the corridors. The second factor is population density. So this is kind of a gross measure, but the traffic and all the commercial activity, et cetera, would be pretty closely aligned to population density. And so here we're favoring areas with higher population density as another metric. So the reason, by the way, for non-Tesla DC fast, that is Tesla brand chargers are proprietary and you can't use them with any, just any electric vehicle, at least at this point. So that's why those are segregated. And then DC fast is a type of charger that's intended for quick charging during, a trip as opposed to overnight. So that would be more advantageous for corridor charging. And that's kind of the target that's being planned for the new stations, fast charging. So here we're saying we don't want to be near existing chargers. So our higher suitability values are in the ranges of 10 miles from the nearest charger or farther. And so the effect of that is we're favoring locations that are distant from existing chargers. There are several other metrics that we have in the library for this sort of metric about the existing stations. So I think you get the idea. Each one of these has a set of preset suitability factors that are part of this map. And I can simply look at the map, I can click on it to get a suitability factor, 87. These aren't absolute values, they're just relative. So if you compare two models together that have different siting factors and assumptions, they're not really comparable. It's just a relative score from 0 to 100. So that's really, I just want to suggest that's a starting point. And everybody has different priorities and needs. And so this customized model button is really important. This model editor dialog lets you modify that starting point any way you like. And let me close that a second. When I get into find suitable areas, I can create a new model from scratch. So it's the same dialog. It just has pretty much a clean slate that you can build a model from scratch. Okay, so now, and I forgot to mention, so this DOE, DOT, interim guidance, DACs, and tribal lanes. There are some funding programs right now that favor certain areas that are disadvantaged from a transportation standpoint. And the Department of Energy and the Department of Transportation have created a mapping of disadvantaged DAC communities, and tribal lands are given the same priority. And the stated goal is that 40% of the funding will benefit these communities. Now, that is a very gray term, and I'm not going to get into all the dimensions of equity, or not really able to in terms of my expertise, but it's enough to say that we can include a layer like this in our model and that takes into account equity or some metric for it to help us focus the results on an area that we want to focus on based on some equity metric. So this is a simple example, but there's a whole set of demographic variables that went into this particular layer, and this can highlight areas on the map that are within these particular selected communities. So in this case, we're just giving 50% suitability for those areas outside of these regions, and if it's within them, it's 100. So in terms of modifying the layer, we can start by the weight. So if there is some factor here, siting factor, that you feel is much more important to the analysis than another one, you can increase these weights up to 5. So this gives a higher weight. And secondly, you can make adjustments to the assumptions within it. So if we go back to population density and say we want to favor rural areas that are less populated, but they're along the corridors and meet the other criteria, I can actually reverse the suitability scales and favor areas that are less populated. So I can make any adjustments I want. If I want to remove one of the layers, you can click this icon to remove it. And if I want to add a layer of any type that's available in the library, say we want to be near a historic, or well, we want to avoid these national scenic or historic trails, just as a quick random example. This would keep us farther away from the trails as just a quick metric to add. Once we've made these changes, we can run the model. And but there's a progress bar at the top right, and you can see it's going to take a while for this model to run. So I'm not going to wait until it finishes here, but this will complete the cycle. It will compute a new suitability map. It'll be added to the lower right here under My Models, and you can download those results and, of course, review them on the map. Okay, let's go back to that corridor map. Well, actually, let me get at it a different way. So you can see how to step through and get it that way. If we go to the layer catalog, we can go directly to that pre-computed model output. In fact, before I do that, why don't I just click electric vehicles, and that's going to pre-populate my map with a whole set of layers that relate to electric vehicles. And then let's go to model output, and I'm going to filter to make it quick, and I'm going to click the corridor model. So that's just another way to get at these pre-computed versions of the models, and I can drag and drop it to put it lower in the drawing order. So here you can start seeing that the higher suitability areas correspond to these designated corridors. The green lines indicate that the corridor has enough charging stations to be considered corridor ready, although the standards for a corridor being ready have gotten more stringent recently. And the dashes would be areas with gaps. If we want to take a look at those disadvantaged community designations, can just, they're already there on the map. We can add it through the catalog or just have it on the map. Find that layer. Here we go. Okay, so these regions, now they won't always be highlighted in the higher suitability because there are other siting factors, but all other things being equal, this particular model would favor this area, because if you were to site a station within the boundaries, then there would be some additional funding priority given to it. So the point is that you can review the model results in connection with the layers that went into it and visually evaluate those on the map. If I were to just click on the features, I can get kind of look up information about each of those superimposed features to see what's at that specific location. So for example, this corridor is signage ready. It was designated in round 3 of the electrical vehicle corridor designations. It's on I-70, and a lot of other real useful details there. It's within, this is the GeoID. This is actually the census, I believe, tract that DOC is equal to. So you could look up information about that tract. And then the model gave it a 49 out of 100 in its suitability. Okay, what else? If you were to not like the results, you see something that's not happening as you would expect, you could take each of those modeling inputs and look at them individually, look at the scores going into the model and suitability values that you assign to them. You can really fine-tune this thing and get a deeper understanding of what led to getting a certain mapping output. As part of our plans for the next rounds, we do plan to have a little bit more analytical tools added to help you with the modeling results and understanding them. But for now, the main addition is to be able to download results for yourself. All right, that's kind of a synopsis of the capabilities of the tool. I appreciate your attention and interest in the tool. Hope you find it useful. And please reach out by email. There's a link on the homepage there. If you have any questions, you can email gem@anl.gov. And hope you get some good use out of it. Have a good afternoon.